4.3 Logarithmic Functions. We start with this definition of a logarithm, and you see this equation right here, y equals log base a equals x. So it's important to understand that a logarithm is the inverse of an exponential. And so most of the times it is useful for us to be able to go back and forth between a logarithm and an exponential. And so we say that these two things are equivalent statements. Okay. So it's important to notice this first sentence says for all real numbers y and all positive numbers a and x. So in here you've got a and you've got x. You've got a and you've got x. Those things have to be positive numbers, and a does not equal 1. So those are just kind of some stipulations there. But we're talking about logarithms here. All right. Now, I want you to remember a couple of things, okay? So memorize these two questions. Question 1, what is the base? When you're converting back and forth between logarithms and exponentials, it's going to be really important that we talk about what is the base, all right? So a base, I kind of, the thing that I draw back on is like cheerleaders, okay? So if you look at an exponential like 2 to the x, I think about cheerleaders making a pyramid. And what happens is the stronger cheerleader is usually down on the bottom, and we call that cheerleader the base. This is the base of the exponential, and the base cheerleaders are holding up the itty-bitty one usually. It's usually a little bitty one. And that's called the flyer. But you've got the base of that exponential is 2. So that's going to be important for us to be able to understand what is the base. Also, when we read a logarithm, log base a, right there. So log base a, or here's your exponential, here's your base a. That's kind of what I want to notice when I'm looking at a problem. And then the other question that I want to think about, or I guess it's not a question, but the answer to a log is the exponent. Now I put answer in quotes because that's not technically what I mean, but what a log equals. Okay, whatever the log equals is going to be the exponent. And so in this box here, the log is equal to that y. And if you notice over here, that exponent is the y. So the thing that the log equals, the answer to the log, is an exponent. You remember those two things, and you'll be able to convert pretty easily. We look at example 1. It says complete the missing equivalent form. So we're just going to complete this box here. We're going from exponential 3 to the 4th equals 81 into the logarithmic form. So I always ask myself first, what's the base? So in this problem, the base is 3, so I know it's going to be log base 3. That 3 is a subscript. It's going to be little bitty and kind of underneath the g. And then I say, I know the answer to a log is the exponent. And so the exponent is 4, and so that means that what the log equals is 4. That log base 3 is going to equal 4. And so by process of elimination, the only other spot there, that's where your 81 goes. Now as for the sizing, sometimes people mess up the sizing. All of the letters and numbers are the same size. The 81, the 4 is the same size as the L. The only thing that's different is that 3. The base number is a subscript, so it's little bitty and lower. Moving on. Log base 1/2 of 8 equals -3. The base in that problem is 1/2. The answer to the log is the exponent, so that's going to be -3. And by process of elimination, the only other number is this. Now, exponential form, I think, is easier for our brains to understand. We see 1/2 to the -3rd equals 8. And remember what we do with negative exponents. That negative exponent is going to flip the 1/2 into a 2 and then cube it, and that's where that 8 comes from. So you should be able to understand that a little bit better. Now we're going back to logarithmic form. It says base 10, so I know that one's going to be a log base 10. And the answer to the log is the exponent, so it's going to equal 3. So it's log base 10 of 1,000 equals 3. Continuing, this is a base 5, log base 5. The answer to the log is the exponent, and that's going to equal 1 over 125. Next, this is a base 12, so I'm going to say log base 12. The answer to the log is the exponent, and so log base 12 of 12 equals 1. This is going to be something good to remember. If I said log base 12 of 12, that's 1. Log base 4 of 4 is 1. Log base 13 of 13 is 1, so that's something good to remember. As is this next one, log base 6 of 1 equals 0. That's a base 6, exponent 0. Of course, 6 to the 0 power equals 1. Moving on, number 2, solve each logarithmic equation. These really aren't so bad, but you're going to want to convert to the other form. I don't like it in log form. I'd rather do it in exponential form, so I ask myself those same two things, okay? What is the base in this problem? Well, it's a base x. The exponent. What is the exponent in this problem? Well, the answer to the log is the exponent. That's negative 2. And so process of elimination, x negative 2, x to the negative second power equals 16 over 9. Now, one thing that's kind of tricky is that negative 2, but we know the negative exponent flips it. So if we know that negative exponent is a flip, then we can say x squared is equal to 9/16. That negative just flips the fractions. So we know how to solve this. We take the square root of both sides, the plus or minus square root of both sides, and we would get x equals plus or minus 3/4. Now don't circle that because there is a problem. Okay? If we go back to the definition for all real numbers y and all positive numbers a and x, that base number a has to be positive. And so when we look at this problem, that base number is x, that has to be a positive number. And so we know x must be positive. So the answer is just positive 3/4. I think that's kind of tricky. They won't always be that tricky. Let's look at the next one. I see that it's a base 16, and the answer to the log is the exponent. So we have 16 to the 3/4 equals x. In order to do this problem, you may have done a problem like this before in an earlier section, but I would recommend you break down that 16. 16, if you think about breaking down a 16 into primes, I hope you can do that in your head, but 16 is 2 to the 4th. So if I break down that 16 into 2 to the 4th, we have 2 to the 4th to the 3/4 equals x. Okay? This is a power of powers problem. If you've got two powers in a row, you multiply them. 4 times 3/4 is just 3. We have 2 to the 3rd equals x. So x equals 8. And then question C. The first step is to change it to the other form. We have a log, we want an exponential. I see a base 36, and the answer to the log is the exponent, and that's going to equal the square root of 6. The key to a problem like this is if you can make the bases, or the two sides match. The two sides match. I have a base 36, and then over on the other side I have a square root of 6. It seems pretty easy to change the 36 into a 6. I can say 6 squared to the x equals, and then a square root is like the 1/2 power. So 6 squared to the x equals 6 to the 1/2 power. So again, we're going to multiply those exponents. That's 6 to the 2x equals 6 to the 1/2. And in order to continue from here, these 6's are going to knock each other out. It has to do with logarithms. We haven't really seen a problem like that quite yet, but those 6's are going to knock out, and I see 2x equals 1/2. I hope you can do that in your head. 2 times what equals 1/2? Or, if you need to change it into decimal form, 2 times something equals 0.5. We're going to divide by 2 and get 0.25 or 1/4. Mathematically over here, when you divide by 2, how I would do it is I would say, well, there's already a division symbol here. So when I divide by 2, I see that there are 2 2's. That's 2 squared, that's 1/4. X equals 1/4.